In this video, we'll solve the differential equation y double prime of t minus 3y prime of t plus 2y of t equals e to 2t using the method of undetermined coefficients. So, let's say the general or the solution of this equation is made by a general solution plus a particular solution. So let's start with the general solution. So yg. In order to find the general solution, we start with the equation y double prime minus 3y prime plus 2y equals 0, the homogeneous one. The characteristic equation is r squared minus 3r plus 2 equals 0. We can use quadratic formula, or we can notice that it's factorable, so it's r minus 2, r minus 1, which means r equals 2 or r equals 1. That means the general solution, or the solution to the homogeneous equation, is c1 e to 2t plus c2 e to t. Now let's start talking about the particular solution. So because we are using the method of undetermined coefficients, we are trying to get an idea about, or we try to guess the type of solution we should expect. So we do that by looking at the function to the right. So it's an e to 2t. So I'm going to expect to have e to 2t, but times some constant. Now, the fact that we started with the general solution is showing us that we have r equals 2. It's a solution of the homogeneous equation, and r equals 1. Now r equals 1 doesn't tell me anything, but r equals 2, the 2, it's the same with the coefficient that it's here at the exponent. So this is one solution, so it's one solution of the characteristic or auxiliary equation that matches these two from here. So that means the particular solution is going to have a term or a factor of t in it, and that factor is t to the first because it's only one time here. If it was a repeated double solution, we would have a 2 squared. So now, having this information, we can find the yp prime, which is a e to 2t plus 2at e to 2t, which I can write a plus 2at e to 2t, and then we'll do the yp double prime of t, which is 2a e to 2t plus a plus 2at times 2 e to 2t, or I can put them together as 4a plus 4at e to 2t. And now we'll replace into our original equation. So we'll replace y double prime, y prime, and yp into this whole equation. So it's going to be 4a plus 4at. I also noticed that all the terms have e to 2t, so I'm going to factor it out. Minus 3y prime, so it's minus 3a minus 6at, and then plus 2yp, so plus 2at. Everything is times e to 2t, which I wrote in front, equals e to 2t. So, let's add some like terms here. So I have 4at plus 2at minus 6at, that's 0. And I end up with 4a minus 3a, which is a. So a times e to 2t equals e to 2t. Or in other words, a equals, so here it's a 1 in front, a equals 1. Or we divide by e to 2t both sides and we get a equals 1. So a equals 1, which means the particular solution is equal to t e to 2t. So the solution of the equation it's C1 e to t plus C2 e to t, which is the general solution, plus t e to 2t, which is the particular solution. Now, if you had initial conditions, then you would replace them into the final equation, into the final solution to find C1 and C2, and you should expect to have two initial values.